everyone, I am the Silicon Fox and welcome to today's video. Gaming graphics have come a long way, but not all systems can run the latest titles at the highest settings. Whether you are running an older PC or a budget-friendly laptop, getting the most out of your gaming visuals can feel like a trade-off between performance and quality. But what if you didn't have to choose? And that's the question being proposed by researchers at Santa Clara University. Today, I just want to briefly touch on a technical paper that was published by those researchers and backed by FutureWay Incorporated. And from what I could tell, FutureWay is a company that really, and I mean really, leverages open source IP for their own research, development, and product support. Now, I should mention that this company seems to be based in Shenzhen, so take that for how you will. Though, without further ado, I introduce you to Game.IR, or Gamer, a groundbreaking dataset that's helping to transform image restoration and super resolution in gaming. Today, let's take a look at how Gamer's cutting-edge technology can redefine graphics and offline rendering, pushing the boundary of what's possible without needing top-tier hardware. Gamer is a first-of-its-kind dataset specifically designed for gaming image restoration and enhancement. It contains real low-resolution and high-resolution image pairs from gaming environments, allowing models to learn how to upscale gaming images in real time without needing artificially degraded training data. And this is in stark contrast to how Nvidia trains their DLSS models. In fact, let's really quickly, or as quickly as I can, break down the differences between this and DLSS before moving on. So, Gamer. Its main goal is to provide researchers and developers with data that mimics real-world gaming visuals, enhancing offline gaming experiences, real-time image restoration, and dynamic scene rendering. Then there's DLSS. This is a proprietary technology developed by Nvidia that uses deep learning to upscale lower resolution images to a higher resolution in real time. DLSS is feature-built directly into Nvidia's RTX GPUs and is focused on boosting frame rates while maintaining high visual fidelity. DLSS uses pre-trained AI models that predict and fill in missing pixels, allowing games to render at a lower resolution and still deliver sharp, high-quality visuals. Gamer is not tied to any one hardware vendor. It is a GPU-agnostic dataset, meaning it can be used to train super resolution and image restoration models for any hardware platform. The models trained using Gamer can be applied to a wider range of devices, making it more versatile in terms of usage beyond just Nvidia GPUs. Its primary function is to help train models to improve image quality on any hardware that supports super resolution. And as we know, DLSS is an Nvidia specific, so not really much to compare there. Gamer focuses on providing a dataset with low resolution and high resolution image pairs derived from gaming content. This dataset is aimed at improving restoration techniques by offering realistic training data that simulates real gaming scenarios. The dataset includes auxiliary data like depth maps and segmentation maps to further improve the accuracy of image restoration techniques. And this is fancy speak for actual low-res game captures and renders. Believe it or not, DLSS isn't trained by just lowering the resolution in some games and having the models look at that. Nvidia has actually created lower resolution samples to train their models on, as so to get the best possible output. There's a saying in AI model training, garbage in, garbage out. There's pros and cons to this, a pro being that the model's output can be extremely accurate, but a con is that training will be much slower than DLSS, even excluding the large scale Nvidia has as an advantage. Gamer can also be used for tasks like novel view synthesis or generating new camera angles dynamically. Yeah, you heard that right. Since the models are being trained on actual game data in real scenes, the models could actually build camera scenes on the fly. The example cited was racing replays shown from completely new angles. So, instead of a programmer making that specific track and camera for that one angle of the replay, the AI could just do it dynamically and from any angle, since it was trained on the game's actual scene data. I could also see this being used for kill cams in games like Call of Duty or Sniper Elite. The AI has the entire scene's information, so it would be trivial to show you a novel angle of your attack. Again, since this is a GPU-agnostic piece of kit, you don't need any sort of special accelerators. GPUs from over 10 years ago could run the calculations. And those are just some of the main differences between the two. So now that we've separated the two key technologies a bit, I want to highlight the benefit of this tech that stood out to me the most, and that was its potential to be GPU agnostic. The models are trained for Game.IR can be adapted to run on various hardware platforms, whether it's Nvidia, AMD, Intel, or even, Qualcomm. And trust me, they need all the help they can get. The tech doesn't rely on any proprietary features, making it widely accessible for all gamers. It of course would take a lot of legwork from devs to get it working in their engines, especially Unity and Unreal, and this is something that Nvidia and AMD have had years to streamline, though it's not out of the realm of possibility for them. I mean, FSR kind of came out of nowhere, and I think this has potential to be much better than like FSR 2. Game.IR is trying to enable new experiences on a wider stretch of hardware, and I can't help but respect that. I like to admire the bleeding edge of tech, just like everyone else, but it is nice to see some love and research being poured into what most would consider obsolete hardware. Though, maybe this is all for naught. Could this be the future of gaming on mid-range hardware? A better, more dynamic FSR? Let me know your thoughts down in the comments below. And of course, please don't forget to subscribe for more insight into gaming tech that's really pushing the limits. I love making this content, but it is a bit more research intensive than normal stuff. I want to make sure that I'm not just doing the bare minimum with the content that I produce. This paper was 19 pages of just sheer technical density. I even reached out to the authors and researchers for comments, but at the time of recording, I have not heard back. If I get an update, I'm gonna definitely follow up. So again, thank you so much for the support, and I'll see you all in the next one. This is Silicon Fox, signing off.